For billions of years, our solar system operated like a private neighborhood. The planets, moons, and asteroids all followed predictable, bound orbits around a sun. And then, quite suddenly, something slipped past the gates. In October 2017, astronomers detected an object moving at such an immense velocity that it couldn't possibly be tethered to our sun's gravity. They named it Oumuamua. In Hawaiian, the name translates to a messenger from afar, arriving first. Calculations indicated it had been drifting unattached through the Milky Way for hundreds of millions of years before this chance encounter. The data confirmed that our solar system is not a closed circuit, but a destination for objects crossing the interstellar void. Observers quickly realized its physical shape defied expectations. It was dark, highly elongated, and tumbled end over end, resembling a massive, rigid cigar. This diagram compares Oumuamua's proportions to a typical asteroid. The data suggests a 10-to-1 ratio, meaning it was 10 times as long as it was wide. As it made its blistering dive around our star, Oumuamua was subjected to immense gravitational and thermal forces. But as the object swung past the sun and began heading back out into deep space, its trajectory shifted. It actually sped up, pushing itself away from the sun faster than gravity alone would allow. While an unusual shape is a curiosity, a sudden, unexplainable acceleration violates the standard laws of orbital mechanics. To figure out how an object accelerates in a vacuum, astronomers look for natural propulsion systems. Usually, that natural propulsion system means it's a comet. When comets get close to a star, the intense heat vaporizes their internal ice, cracking open the surface to spew jets of gas, acting exactly like tiny, powerful rocket thrusters. The powerful telescopes looking directly at Oumuamua, however, saw absolutely zero outgassing. The object was completely dry and left no tail behind it. If not a comet, the next assumption was that it was simply an oddly shaped asteroid. But inert rocks are bound by gravity. They cannot generate their own thrust to speed up on their way out of a star system. With comets and standard asteroids entirely ruled out, scientists were staring at an object defying the known laws of natural planetary bodies. Analyzing the void in the data, astrophysicists at Harvard University proposed a different force was driving the object forward, the literal physical push of solar radiation. This animation illustrates radiation pressure. When sunlight strikes a reflective surface, it imparts forward momentum. To physically push an object the size of Oumuamua, it couldn't be solid rock. It would need to be lightweight, likely less than a millimeter thick. To achieve that level of thinness while maintaining its structural integrity, the object would have to be an artificially crafted structure. This led to the hypothesis that Oumuamua might have been an artificial lightsail, a massive, shimmering sheet designed to catch the sun's radiation. This was a mathematically sound hypothesis, reverse-engineered from the precise trajectory data it left behind. The flyby forced the scientific community to re-examine the known limits of physics. Today, we are left with two possibilities. Either there is an unmapped mechanism of natural physics at work in the galaxy, or a piece of artificial technology just coasted through our solar system. By the time we processed the data, Oumuamua was already crossing the orbit of Jupiter, moving too fast for any human spacecraft to catch it and confirm its origin. If you want to explore more deep space mysteries, hit the subscribe button. Regardless of whether it was a bizarre rock or an artificial probe, Oumuamua lived up to its name. It arrived as a messenger, forever changing our expectations of what is drifting in the dark.